If you're someone who's looking at how can you deploy LLMs and what is a right inference backend for serving large language models, this is a very interesting report from or a blog from uh, BentoML. So here they have benchmarked LLM inference backends. So the various LLM inference backends which they looked at are vLLM, LMDeploy, MLC-LLM, TensorRT-LLM, and TGI or text generation inference from Hugging Face. So why is it important for you to choose the right inference backend for serving large language models? It is important because it determines the optimal user experience with fast generation speed, but also, it needs to improve cost efficiency through a high token generation rate and resource utilization. Right? So these are the key things which drive your choice of inference backend for LLMs. So the response time and cost efficiency for token generation and resource utilization. So here what they did was they did a comprehensive benchmark study. They used the Llama 3 LLM. They used the 70 billion parameter Llama 3 with 4-bit quantization, and they also looked at Llama 3 8 billion model. Okay, so what is the metrics they are looking at over here? So the metrics is time to first token. So this measures the time from when a request is sent to when the first token is generated. It is in milliseconds. So this is important for applications which require immediate feedback, such as interactive chatbots. Lower latency improves perceived performance and user satisfaction. So that is the idea of time to first token metric. So it's like when a request is sent, how fast is the first token generated? It is typically in milliseconds. The next one is token generation rate. So this is about how many tokens the model generates per second during decoding. So it is measured in tokens per second. So if the token generation rate is higher, then the model can handle high loads. A higher rate suggests that the model can efficiently manage multiple requests and generate responses quickly. Okay, so these are the two metrics. So what are the benchmark findings? So they did this benchmark study using the Llama 3 8 billion parameter model and the 70-bit Llama 3 but 4-bit quantization model on an A180 GB GPU. This GPU is on BentoCloud and across 3 levels of inference loads, 10, 50 and 100 concurrent users. Okay, so this is their benchmark study which they did. And what is the findings over here? So what they say is that LMDeploy, okay, if you look at these graphs with user is equal to 10, user is equal to 50, user is equal to 100, for the token, basically the first token generation, right? Time to first token generation. If you look at these graphs, it is very clear that LMDeploy is the best among these inference backends and it produces the fastest response when compared to the other backends. Okay, fastest first token generation in terms of milliseconds. Okay, so LMDeploy delivered the best decoding performance in terms of token generation with up to 4,000 tokens per second for 100 users. It also achieved best in class token time time taken for first token with 10 users. That is what they are saying over here. Okay, so with respect to Llama 3 8 billion, so here is that the token response tokens per second, the second metric token generation rate, and this is the first metric, time to first token. So LMDeploy seems to be the best backend over here with respect to these two metrics for this particular model. Okay, then compared to LMDeploy, you have also MLC-LLM, which is slightly lower decoding performance. It's about 3,500 tokens per second for 100 users. But it showed performance degradation, and it also had the time also kind of degrades when the number of users increase. Okay, so these two backends are better for Llama 3 8 billion parameter models when compared to vLLM or say when compared to the, but vLLM also, if you see over here, when the users are close to 100, if you see over here, the time taken for first token is much lower than all the other backends. Okay, but then if you go over here to vLLM in terms of tokens generated, it is somewhere around 2000 tokens generated per second, okay, for 100 users. So you need to compare this and see what is your user scope, and depending upon the number of users, probably you need to repeat these tests to find out which is good. But in their study, they are saying LMDeploy seems to be the one of the very good backends. Okay, so that is the conclusion for your 8 billion parameter models. Okay, vLLM also achieved best in class for across all levels of concurrent users, but decoding performance is less optimal. Okay, that is the compared to say other backends like the text generation inference or TensorRT-LLM. Compared to them, you can look at either vLLM or LMDeploy over here, or maybe even MLC-LLM, okay, as an inference backend. Now, if you go to Llama 370 billion parameter model with 4-bit quantization, over here, if you look at, depending upon the number of users, if you were to look at the time taken for first token generation, again, LMDeploy seems to be better when compared to the other platforms over here. Okay, and vLLM is okay in comparison over here. Okay, but if the users are 50, then again LLMDeploy, then you have TensorRT-LLM. Okay, but if you look at say the response tokens per second or token generation rate, again if you look at LMDeploy seems to be the best, and next to that is TensorRT-LLM over here. Okay, so with the larger 70 billion 4-bit quantized model over here, TensorRT-LLM seems to be good when compared to LMDeploy for generating tokens, right? The token generation rate is faster over here. Okay, so LMDeploy delivered the best token generation with up to 700 tokens when serving 100 users, while also keeping the time TTFT, basically time taken for first token, across all levels of concurrent users. Next is TensorRT-LLM. Here vLLM seems to be consistently low. It had low time over here when compared to say time taken for first token is low, but then again the token generation rate is less. Okay, so that is the thing over here. So this was about the performance on their benchmark. Now you have to actually take a lot of decisions for you when you are choosing a particular LLM inference backend. It could be like which models are supported by these particular inference backends. It could be about what are the hardware limitations of these particular backends. Okay, for example, only some of these like LMDeploy and TensorRT-LLM only supports NVIDIA CUDA, whereas vLLM, it supports on AMD, it supports AWS Neuron, CPU and other things, right? Similarly, text generation interface from Hugging Face also supports a different kinds of hardware, right? Again, you have to check whether your models are supported, what kind of quantization is supported. So there are other parameters by which you can actually choose your ideal inference backend. So that's the key message over here. The kind of backends which you can choose based on this study, it is LMDeploy or vLLM or TensorRT-LLM depending upon your use case, right? Other details are present about what is the how stable are these platforms, and what is Llama 3. I wouldn't go into this, so you can check it out. Okay, so this was about which LLM inference backend you need to choose and what could be the metrics for evaluating these LLM backends. Now you can define your metric depending upon your use cases, but a good metric is the token generation rate, which is about how many tokens the model generates per second during decoding, measured in tokens per second. Other one is like depending upon how fast you want a response back from the LLM for interactive immediate feedback kind of chatbots, it is the time to first token. So this is a very informative blog. You can read over it. I hope this video is useful to you. If you like the video, please like, share, subscribe to the channel. I'll be putting the links to this blog and as well as all the other, your inference backends like vLLM, your LMDeploy, TensorRT, so on. See you in another video.